Hi, today we'll see more examples regarding our input variables and also especially if-else condition. So here is one example to check the passcode. So if a passcode is a whole number between 4 and 9 digits inclusive. So here is a passcode where is between 4 and 9 digits. For example, if lengths are these are the valid passcodes because they are between 4 and 9 digits. However, if it is less than 4 digits like 123 or 8 or more than 9 digits, then they are invalid codes. And we need to write a program that asks the user to choose a passcode and then validates that passcode. So if the passcode has 8 or 9 digits, we print passcode is secure. If it is 4, 5, 6 or 7 digits, we print passcode is not secure. And if the passcode is invalid, that is less than 4 digits or more than 9 digits, we print invalid passcode. And here is an example that I choose a passcode like a 3452 if it is entered, then the passcode is not secure. And choose a passcode 111, it is invalid. Okay, so let's see an example how to implement it. So as always, we start small. First, let's get the number from the user. So we say n is equal to, if I just first get the number, enter the number, we can say should be between 4 and 9 digits inclusive, so we can say 4 and 9 digits. Now if we print it, if we run the code and enter number, let's say 555, although it is, we haven't got the input, but it is not a number, it is a string. To make it an integer, we have to put it int. For example, if I want to print its type, print type of n, and I run my code, I say 555, it says type is string. So we need to convert it to an integer. So if I place here integer, so this whole input always gives me string. Whatever that string is, I gave it to integer. Now if I run it and I enter my number, so it is integer and I got the number. So at least now it is a number. I don't need to print the type, I can remove it, but it's always good to throw some print statements for debugging and then we can remove it. So first check if the number is less than 3 digits, it is invalid. So I can check it if n is, so what is the, how can we check if it is at least 4 digits? So what is the lowest, smallest 4-digit number? I mean 999, this is a 4-digit number, but is the largest 4-digit number. 900 is also a 4-digit number. 8000 is also a 4-digit number. So the smallest one is 1000. If I go smaller than 1000, it becomes 999, which is a 3-digit number. So the smallest 4-digit is 1000. So if n is less than 1000, I can say it is invalid. So I can check my code. If I run it now, if I enter 555, it prints invalid. And if I enter 4-digit number, it just print the number, it does not say invalid. Okay, so I got the check for the 4 digit. Now if it's a more than 9 digits, it should also be invalid. So I can have another check it, elif. So if first is check, if this check is false, then check the second one, else if n is greater than. So it means these 9 digits, I can't have spaces in between, but I keep track of these are the 9 digit number. So if it is n is greater than this, it is still invalid. Let me run it. So now if I say 1 1 2 3 1 2 3 1 2 3, it prints invalid. And if I print 1 2 3 1 2 3 1 2 3, it's the largest 9 digit number, it is still valid. Okay, now one more thing we can see, I can do it separate, or we can combine these two conditions together, because whether n is less than 1000 or n is more than these 9999, it is invalid. In both these cases it is invalid. So I can combine these two conditions by using OR operator, or n is greater than 1 2 3 1 2 3 1 2 3, and then in that case both of them it is invalid. So I can save my one if condition. Now if I run it and I enter 3 1 2 3 1 2 3, one more 10 digit, it says invalid. So it is working. Now you can see it if n is less than 1000 or and it is working. There is another way of doing so. So there are 3 ways of doing it. Either I can do like this, case 1, or another way of doing the one I did earlier, n is less than 1000, print invalid, elif n is greater than 3 3 3, print invalid. So in both cases it is printing invalid. So if I run it and enter 100, it will invalid in both the cases. There is another way of doing the same question as well. I can say, okay, here is case 3. These are the comments I can write with the hash sign. Case 3, I can even combine them if there is no case 3. Case 3 will be valid case. Okay, so maybe we can use this first one and I can remove the second case. Now the other one is now to check if it is insecure or secure. So if it is greater, if it is 8 or 9 digits, then it is secure. So in the else part I can say elif. Now how to check if it is at least 8 digits? So these are 3 4 5 6 7, you can separate them. So these are 7 70. So if it is more than 7, it is a 8 digits. So in this case I can say this passcode is secure, and all other cases 4 5 6 7, they can go in the else case. I can say passcode is insecure. So if I run Now I say 1000 passcode is insecure, and if I run four digits 5, 6, 7, 8 digit, then passcode is secure. Three, 1, 2, 3, 1, 2, 3. Now it's a 10 digit. It should be invalid. Okay, so we got this question done. So we can remove these extra stuff, we don't need them. So if n is less than 1000, it means if it is 3 digits or more than 9 digits, it is invalid. If this is false, so it means it is more than 3 digits and less than 10 digits. Only then it will come here. So then we check if it is more than 7 digit. So if it is more than 7, it must be either 8 or 9. It can't be 10, because if it is 10, it will be here. So 3 digits and less are here, 10 and more are here. So only if it is between 4 and 9, it will be false and it will come here. And in this case, we'll filter first, which are only smaller cases. If it is greater than 8 digits, so passcode is secure. And in this else will come 4 digits, 5 digits, 6 digits, 7 digits. Okay. Now let's check the other question. It's a simpler one. So here's a question regarding the date validation. So for web forms, they validate the values entered by the user, highlighting the invalid text boxes in red and forcing the user to correct their input in order to submit. One common type of error information collected when signing for new account via web form is birth dates. Writer asks the user for the day, month and year of the birth and validates whether it is a valid date. And the year must be between 1900 and 2018 inclusive. If the year is invalid, print out invalid year. The month will be between these inclusive. The month is invalid, we print out invalid month. Similarly, we check for the day also. And for February, if 29 days for leap years, which are multiples of 4 with the exception of years divisible by 100 but not by 400. And these are the days for 30 days, all the months are 31 days. Okay, so if you enter day 31, month 2, year 1894, it is invalid day because we can't have 31 in February and invalid year. And if we enter a correct day, then there is no error message. So let's implement these things. We need to get the day, month and the year, and we check it. A new file. So first I get my 3 inputs. I say year is equal to integer input, enter year, and then month is equal to integer input, enter month, and then day is equal to integer input, enter day. And now I got these ones, and now to check it. So So if year, again similar check, if year is less than 1 or year is more than if year is less than 1900 or year is more than 2018, so then we'll enter print invalid year. So 1900 and 2018 are inclusive. Now in this case, since we need to check both year and month, so we'll not use elif as we did in the previous question. And over here we only check this condition if the previous one is false. So it means if there are 3 digits or 10 or 11 digits, we print invalid and we ignore all these things. But in this case, even if year is invalid, we still need to check if whether month is invalid or not, because at the same time we have to show the user all the invalid entries in the form. So it is not elif but just if. So if month is less than 1 or month is greater than 12, we print invalid month. Okay, so we get the month also. So we can check it. So if we run the code, we say enter year, I say 1894, enter month which is 13, day 28, invalid year, invalid month. So we check the both. Now to figure out the day. To get the day, first we need to determine if it is a leap year. So how to check if it is a leap year? To make a variable leap year is equal to the year. So leap years are the years which are divisible by 4. So remainder is, it means if we divide by 4, the remainder is 0. So this is the mod function remainder. So if remainder is equal to 0, it will be true. So I can print the value just to see if it is correct. Let me see what it is. I run my code and I enter 2016, 2 and 2. So yeah, so 2016 is a leap year. And if I enter 2018, it is not a leap year, false. But there is another rule that even if it is divisible by 4, if it is divisible by 100, it is not a leap year. So 1900 is not a leap year. In this check, if I enter 1900, it says it is a leap year. So even though this check is making it true, 1900 make it false. So I will say leap year is equal to the previous condition, leap year, and year mod 100 should not be equal to 0. So this one, if it is divisible by 4, it will be leap year, but like 2016. In 2016 this is true, but 2016 is not divisible by 100, so it will remain leap year. So 1900, this will be true, this will be false, so it will become false. Let's try it. So if I try 1900 now, it says it's not a leap year. And if I try 2016, that is a leap year, so it is correct. But there is another rule that if it should not be divisible by 100 but divisible by 400. So this is the one divisible by 4 and not divisible by 100. third thing is, it again becomes a leap year if it is divisible by 400. For example, 2000 again becomes a leap year. If it is divisible by 400. Now if I check, and why it is odd? Now imagine if it is 1900. So 1900, this is true, this is false, because 1900 is 0, so it should not be 0, so this is false. So false and true and false, it gives you false. But for AND, both conditions have to be true, it becomes false. 1900, so this is false, and 1900 is not divisible by 400, so this is also false. So false or false gives you false, so it is not a leap year. But let's say 2000, this one is true, but it is also divisible by 100, this will make it false. Just like 1900 is false, for 2000 this is false, this is second is false, but we need to make it true again. So although this one is false, because 2000 is divisible by 100, since it is divisible by 400, we need to overrule it, so we put OR in between. So even if this was false, but if it became divisible by 400, we'll make it true. Let's try it. So now if I print year 2000, it is true, it is a leap year. But if I make it 1900, it is false. So it is, so leap year is working correctly now. So it should be divisible by 4 and not divisible by 100, but if it is divisible by 400, it is still a leap year. Okay, so we got the leap year, we don't need to print it, it was just for debugging. Now we check the month. So if day, now we check the days. If day is less than 1 or day is greater than 31, then we can print invalid day, because right away it has to be within that range. Now one more thing, we can also check if those days, when the days should be 30. So day is 30. In which month days are 30? So when month is equal to January, February, day is equal to 3 or 4, or month equal to 6, or month equal to September, or month equal to November. It is double equal, not single equal. In all these cases, whether month is 4 or month is 6, is April or June or September or November, in all these cases days should be 30. So I just make this boolean. So I check it. So if day is less than 1, these two conditions, leap year and day is 30, these are two boolean variables which will be helpful in checking these days. So if day is less than 1 or more than 31, it is invalid. If I check if month is equal to 2, so it is second month. I check it. If it is leap year, because this is a leap year boolean, and day is more than 29, like a 30 or 31, so then in that case it is invalid. Or I can check it if it is not leap year and day is greater than 28, or should count greater than 28, then it is also invalid. But in this check is only done when month is 2 in February for leap year. If leap year and day is more than 29, like 30 or 31, invalid. And if it is not a leap year, not is a unary operator, and or are binary. In and you need two conditions, one on left side, the other on right side. Same thing for or, one condition on left side, one condition on right side. However, for not, there's only one condition. So not leap year and is missing here, and day is more than 28, print invalid. And over here we come back, if day is 30, so it means these are the months. If it is 4, and so in these cases only 30 days are allowed. So if this is true, however your day is more than 30, like a 31, which is not allowed, so we print invalid day. Otherwise, if it is not days 30, so it is a valid day, because it is when 31 is valid. More than 31 is already checked here. So let's run it. So if I enter 2016 February 29, there is no problem. It's a leap year. And if I enter 2018, now enter 29, is invalid day because it's not a leap year. And if I enter 2002 29, it's correct. But if I enter 1900 to 29, it is invalid day. Correct. Okay, so it is, so we are done. Let's check it again. I mean, I can place this all long condition over here as well, but then it will be a bit more complicated condition. I can use this as a variable. Now we take another question. Which is regarding this tennis scoring. It is simplified. One player hits the ball out of the bounds on the opponent's half of the court. The opponents get a point. In our tennis video game, we model the ball skills using an X coordinate and a Y coordinate. So we check the X, Y coordinates. So here is our tennis court. 0 to 50 is one half. 200 is the other half, and this is 0 to 60. So to determine it, so we say if ball is out of bounds on the left hand side over here, player 2 scores a point. Player 2 gets a point. In this game, it could be a different game, different than the real tennis. But over here, if it goes here, so it's point for player 2, this option. And if it goes here, then it is point for player 1. The one thing we need to note, if it is less than 0, if it is here less than 0, then definitely player 2 gets a point. But however, if it is between 0 and 50, we further need to check the value of y. Player 2 only gets a point if y is less than 0 here or y is more than 60 somewhere here. But if x is more than 50 but less than 100 in this region, and again we need to check if y is less than 0, player 1 gets the point. If y is more than 60, player 1 gets the point. But if we keep going and x is more than 100, and then we don't need to check the value of y. So always player 1 gets a point. So let's start it. So we get the value into input enter y, and now if I check if x is less than 0, which is this case, if x is less than 0, then player 2 gets the point. Player 2. However, elif, so it is not less than 0, it is more than 0, but still it is more than 0 but less than 50 somewhere here. So it is more than 0 but less than 50. So now to check it further, if y is less than 0 or y is more than 50, so y is less than 0 or y is more than 60, sorry, more than 60, then in that case still player 2 wins. There is no else part, because if it is here, then the game continues. Nobody gets the point. You only get the point if it is outside. If it falls within here or over here, nobody gets a point and the game continues. Elif, here is x actually. Elif x is less than 100, then again I need if y is less than 0 or y is greater than 60. This time is player 1 and the last is just the else part, because it is here, so we don't need to any other condition. You can say all x, in this case print player 1. So if x is less than 0, it is player 2. We don't need to check the value of y. If x is more than 100, again player 1, we don't need to check. However, if x is more than 0, this is false, it is more than 0 but less than 50, then we need to check the value of y. Similarly, if it is more than 50 but less than 100, we need to check the value of y. So let's run it. So if I say minus x, player 2 gets a point, which is correct. Now if x is, let's say 25 and y is minus 5, so still player 2 gets a point. Or x is 25 and y is 65, still player 2 gets a point. Now if it goes up above 50 and less than 100, like x is 75 and x is 65, now player 1 gets a point. And if x is 75 but y is minus 5, still player 1 gets a point. dash makes 75 and y is, let's say, 25, nobody gets a point. It is in the middle. However, if x is 100, 125, actually 100 is also out in our example. Player 1 gets a point. Okay, so now here's the condition. This was the review of these three questions. The first question was to check the passcode, and the second question was to check the input validation, the date, leap year, and finding. Third one was just tennis scoring.